determined according to this rule. That is, we need to know, and our W is W1 over there, right? So we want to know, is the sentence P true at some world in the modal base? And it is the case, it is the case if we find such a world. So this is our W prime. If there is one, then may P is true here. Whatever. So in this picture, it is actually true. Right? And here it is not true because our W2 is this set and there is no overlap. And the necessity statements, they are a bit different. So for W1 necessarily P. Now here it says, so again, is there a world W prime? Oh no, sorry, not is there, it says all. Sorry, yeah, this is universal quantification. So is the sentence P, right, over there, our case is the sentence P. Is that true at all worlds in the modal base? And that is false for both of these. It's true. It's false at W1 because there are some words here which don't fall under P, right? So this is false. And it's also false here because the modal base is not a subset. That's all. That's all there is to it. The alternative way of writing it, as I said, would be for, now let me write it over here. The alternative way of writing this definition, right? If and only if RW, if you intersect RW with the denotation of phi, and you get a non-empty set, then may phi is true at W. And the necessity clause is the same, except that now here you say RW is a subset, has to be a subset of this denotation in order for the sentence to be true. These two are the same, really, just different ways of saying the same thing. What's important is that we need overlap for the possibility, and we need inclusion for the necessity, right? Now you also see here that it's possible for this modal base not to include the world of evaluation. And of course we want that because, for instance, suppose all the sentences that generate the modal base, remember we have a set of propositions, and this modal base is the intersection of all those propositions, right? There may be a false one among them. If any of them is false at this world, then the world is not in there. So if it's, the law says you have to cross the street only when there's a green light, right? That's the only, you cross, whenever you cross the street, the light is green. So the worlds in which that law is obeyed are ones in which everyone crosses the streets when the light is green. But in our world, that is not the case. There are people who cross when the light is red. So our world is not one in which all of these deontic sentences, these requirements are true. And then our world is not in the intersection of all these propositions. That can be the case, but maybe it is. So we'll get to this in this section of the handout, actually, this very property, whether the world is itself a member or not. Because now we are entering section 5.5, properties of modal basis. But before that, well, I say here frames or modal basis. I want to point out an alternative way of talking about modal basis, namely the one that logicians are familiar with. Everything I said was a little bit non-standard or unfamiliar. I said, just a second. I said that R is a function from worlds to sets of worlds. Well, let me actually write it like this. Worlds to sets of worlds. That is, for instance, from W1, this is one possible such modal base. From W1, it takes you to a function that says W1 is not in the modal base, W2 is not in the modal base, W3 is in the modal base for this one, right? At W2, you get a different set, right? So here you have only the W3. Perhaps here you have W1 is 1, W2 is, and W3 is not a member of the modal base, and so on. So this is a function of this type that I had on the handout. This is the same thing, it's interdefinable with a relation between possible worlds. The same thing, can be written in this way. You have W1 goes to 0, W1, W2 goes to 0, W1, W3 goes to 1, W2, W1 goes to 1, and so on, right? There's a one-to-one correspondence between this way of saying it and this way. Linguists may have seen this as Schönfinkelization. Have you ever heard that term? Or currying, the word currying? Yeah. They both refer to this fact that you can interdefine these. Now this is a set of pairs of worlds. This is a relation between possible worlds. That's how usually these things are discussed in modal logic, in philosophy. And it's quite clear what the correspondence is. So far I have said that R is something which, when at this world, when applied to this world, gives you this set. Well, there is also a relation which takes you from this world to all the worlds in this set. Clearly, there is a one-to-one correspondence between those things. In philosophy, people always talk about relations like this. But you may just as well talk about a function from worlds to sets of worlds, because that's also a relation. Okay? Yeah. So, now in section 5.5, I want to talk about these three things. Modal basis, you may impose certain requirements of them. You may want to say, if this modal base is to be epistemic, then it has to have certain properties. Or if it's deontic, then it doesn't have to have certain properties, and so on. And that's where we enter this realm of modal logic. Three things that I mention here are consistency, realism, and introspection. and let's just see what they are. And always keep in mind that our, what we are after is, what we want is account for our intuitions about the readings of these modals that are interpreted relative to the modal basis. So you may want to say that on certain readings, say epistemic modal base, one that encodes knowledge, the knowledge of an agent, you may want to say that that modal base cannot be empty. That is, the intersection of all the things that someone knows cannot be empty. There has to be a world in which your beliefs are true, or your knowledge, sorry. Otherwise it doesn't deserve the name knowledge, right? Because John knows that his cat died yesterday, entails that his cat died yesterday. At least lots of people think so. If that's the case, well, then there should be a world in which so knowledge should be true belief, right? Things like that. So you can say beliefs as well, not just knowledge, should be consistent, because if you have an empty modal base, an inconsistent set of beliefs, then any sentence follows from it, right? If you have the empty modal base, then necessarily P is true, and necessarily not P is also true. That means you believe P and you also believe not P. You may want to rule that out. It's a weird thing, right? To say that, you want to say that the modal base is consistent. It's on your handout on page 23. And that is just the statement that at all worlds of evaluation, there is some world that is in the modal base. So this is supposed to be a different, you have all these worlds, and the modal base at this world is perhaps this set, right? And at this world is this set, and at this world it's here, and so on. So it has to be empty sets for all of these worlds. Another way of saying the same thing in terms of relations now is that the relation has to be serial. You remember that from the properties of relations this morning. The relation has to be serial, that is, from every world, there is at least one world that's accessible from it. Whatever, something like this. Now this is consistent. These arrows in code, they represent a consistent modal base, because for every world you actually have a non-empty set of accessible worlds in the modal base, right? Okay, and I'm talking interchangeably of this function from a world to sets of worlds. There we say it has to be not empty, non-empty, right? Or these relations between worlds, there we just say that there has to be a world that an arrow takes you to. And some modal bases have this property and others don't. This is related a little bit to the realis and irrealis distinction in linguistics, although people don't actually agree on which modal bases have to be realistic and which don't. Consistent. Oh, we're talking about consistency. The next one is realism. So is this pretty clear? Consistency just means that whatever the world of evaluation is, the modal base is not empty. It's not contradictory. You don't have contradictory beliefs. That's the idea. For instance, if it's beliefs. Laws may be contradictory. There may be requirements. One of them requires you to go to Tokyo and the other to go to LA. You have two obligations, and then you have to make a decision and break one of these requirements, because you can't do both at the same time. In that case, the modal base is itself inconsistent. That can happen. Right. We'll see how we deal with that tomorrow. With using preferences, one is more important than the other, something like that. Yeah, so we see that the seriality of the relation and the non-emptiness of the modal base are the same thing. Realism. In this picture here, W1 was not a member of its own modal base. People's beliefs can be false, can be consistent, but false. Someone may believe that today is Friday. In this world, today is Thursday. Then all the worlds that are consistent with that person's beliefs are ones in which it is Friday. So ours is not among them. Okay? That's sort of the case that we have here, where W1 is not itself a member of this. Now we may want to say of some modal bases that the world has to be a member. For example, that's the distinction between knowledge and belief, that knowledge has to be true. And I already mentioned before, I think, I don't remember whether it was in the lecture or in the break, these obligations, they can be false. Oh, I said that, right, with the traffic light. All the worlds where the laws are obeyed are ones in which people cross the street when the light is green and don't when the light is red. But the actual world is not like that, right? So it's not a member of this. In terms of accessibility relations, when is the world itself guaranteed to be a member of the modal base? Well, that's if whenever there is a loop like this, right? So here there is no such thing. All the arrows go somewhere else. That is, this world is not actually, you can't go there from there. If there is a loop, then this is a member of the modal base, because the modal base is the set of all worlds that you can get to with an arrow, following an arrow. So we have realism. I don't really have to write this down because it comes up in a table on page 27. Realism corresponds to reflexivity of the modal base. On the left-hand side here, you see the statement in terms of this set of worlds, right? RW is a set of worlds, and W must be a member of RW. That is the case if, this is guaranteed to be the case only if R is reflexive. So if we actually have this link from W to W via R, right? And what I said above about serial relations, so we have consistency. There is some W prime such that you get there from R, right? If that is guaranteed to be the case for all worlds, then you have a consistent modal base. And in terms of the relations, that means it's serial. Oh, I mixed up the columns here. Right. RW is not empty, and this clause belongs over here. Right? And you may wonder, so already, deontic models don't have this property of realism. It just doesn't make sense to say that everything that is required is guaranteed to be true. There have to be models in which things are required but not true, because that's what our world is like. So we want to be able to talk about those cases. But when it comes to knowledge, we may not want to say that. And then we have this total realism, which is just a special case of realism. This will show up briefly when we talk about counterfactual conditionals tomorrow. It says that from each world, not only do you have realism, that is, from each world you have this loop around it, but you also don't have anything else. Don't go anywhere else, right? The modal base is the actual world and nothing else, the total amount of information, everything that is true. Actually, no one really knows what's true, but there is such a modal base, right? Containing only the world of itself. And if the modal base in general as a function from worlds to sets of worlds has this property, then you have all these loops everywhere, right? And nothing else. That is, for each world you get just itself. And that is useful for counterfactuals. We see that tomorrow. Well, in the table it is. I don't have to write all of these things. It's the identity relation. That is, every world is related just to itself, nothing else. Okay. And let me say some things about introspection. Positive and negative introspection. They are a bit more tricky. Not much more tricky, actually, but they are important if you, especially if you talk about beliefs. The thing is this here, you have some world, okay, and suppose your beliefs are false, so just so we don't have to include this. And now you have all the set of all these worlds that are compatible with your beliefs. So over here there are, say, 3 worlds, and you have this. Okay. Now these arrows, they are your relation. Okay. All right, so far. Yeah. But now this can't be enough, because now if you go here to W prime, don't you have any beliefs at W prime? Don't you have any beliefs about your beliefs at W? In this case here, see, it's not even serial at the time, at the moment, right? So what do you believe about your beliefs? We have to say something about the relationship between this modal base from the perspective of this world and the modal bases that we get from each of these. Because if we say, for instance, suppose P, some sentence P, right, has this denotation, so the modal base is a subset of it. That is, at W, you believe P, right? I'll put it in yellow. So at W, you believe P. Now, we might have, from this W prime, an arrow going out here into not P land, right? Because everything outside the yellow circle are worlds where P is false. And we may have, from this world here, an arrow that remains, or there's not just one arrow, but we may, for example, have all these connections here, let's say, that stay within P. Now, there is a world compatible, or consistent with your beliefs at which you believe P, right? Namely this. There's also a world consistent with your beliefs at which you don't believe P, namely this. Right. Now the question here, so can you actually it doesn't make sense to say that here you believe P, namely this, but you don't know whether you believe P, because in some of these worlds you do, and others you don't. Do you see that that's a weird thing to say? But that this actually follows this picture, does that? It doesn't make sense really, unless you're talking about some sort of schizophrenic person who has trouble keeping track of his or her beliefs. This is often avoided, especially when we talk about knowledge and beliefs. This situation that from these worlds in the modal base, you are taken somewhere else to a different modal base from what you actually have. Introspection, which really means, knowing yourself, right? Introspection ensures that that doesn't happen. That from each of these worlds in the modal base, the belief, the modal base at W prime is again this very same set. So we have, let me see, this set here, which I'm circling in white, this is RW, and it's also RW prime. Maybe here we have W prime, right? And if we have some W double prime, it's again the same, and so on. And there are two requirements which, two of these properties of relations which jointly together make sure that that happens. I mean, you could just say they have to be the same, but logicians like to take things apart and reduce them to more basic statements. And these two statements here, positive introspection and negative introspection, correspond to transitivity and Euclidity of the modal base. If you say that the modal base, or the relation, right? The relation between worlds that goes with it, it has to have both of these properties, then you ensure that these are always the same. Right? And that you basically know what you believe. We can see that how that happens in the pictures on page 26. They ended up on the same page. For some reason, I don't know. It's a LaTeX thing. Let me actually draw these on the board a little bit so you see. By the way, I do now have a feeling that we won't get into the next section, which was labeled as time permitting, right? Section 6, some logic. That's okay though, so let's stick with this here. Transitivity. I sort of drew it already, but we can look at this picture again. So you have a world W, and an arrow goes into your modal base. Suppose it's this. It doesn't matter here whether W is itself in there or not. And other arrows, they go here and here, whatever. There are all these worlds in the modal base. Okay. The set of things, worlds which are compatible with your beliefs. And if from somewhere here you are taken somewhere else outside of this modal base, so there is W prime and W double prime, then obviously, this is outside the modal base, so there is no direct link. There is always a direct link for all of these things here, right? Whatever you have here, there will be an error because this is the modal base after all from this world. So in here we are fine. The modal base is transitive when you're restricted to this, but as soon as you have an error going outside, transitivity is violated. You can't have this. This W double prime over here, this must be in the modal base as well if the relation is transitive. Now if you say, I am talking about a transitive relation, that means you are saying I am not talking about a case like this. This doesn't happen with my intended reading of the modal. So if you want to talk about epistemic or doxastic modal basis, knowledge or belief, you could just say it has to be transitive. All right. And then you can't have this error up here, and then you don't need this one, and then you're fine because you're staying within this set. And that is, well, the second step now concerns the Euclidity of the relation. Now, if you only have this, the relation is not Euclidean. Remember what a Euclidean relation was? You cannot have this picture without all of these things. Remember? Do you remember? Perhaps, yeah. I'll write down the sentence again. So if W are W prime and W are W double prime then W prime are W double prime. This is the definition for Euclidean relations. Transitivity we can also put up again. Maybe it may be helpful. W this and W prime are W double prime, then W are W double prime, right? Transitivity. Now, but I want to focus on this Euclidean. When is a relation Euclidean? What does it take? So it means, obviously, as I've said before, when you have this picture here from W, you go to these two things, you must also have this connection, both of them, right? It also means, actually, if you think about it, that you must have loops around these. Because let this be your world V, say. You have WRV, V being your double prime, and you have WRV. So therefore you must have VRV, right? Because you have to remember that these two, W prime and W double prime, in this definition, they don't need to be distinct. That doesn't say that. So with the Euclidean relation, you actually get this full connectivity here between all the accessible worlds. That means in here, first of all, it gives you for free, basically, all of the loops. It also gives you all of this, full connectivity in there. That's what Euclidean says. Transitive says you don't go anywhere else. Euclidean and transitive jointly ensure that everything in here is connected and there is no arrow outside of it that goes anywhere else. And that, of course, is just saying that these sets for each of the worlds in here, the accessible ones, are again the ones in this set, all and only those. Okay. Is that? Do you have any questions about this? Any questions about this? perhaps not. Maybe, well, I think it may actually be a good idea to sort of take it easy and think about it a bit more this evening or so, go over this handout again, and just make sure, did you understand it or not, or whatever. Are there still open questions? Whatever, is that right? Yeah. So for example, doxastic, remember those are belief modal bases. Doxastic modal bases about belief. They are usually considered to be serial, transitive, and Euclidean. Those three things. That is, from every world you go somewhere. Your beliefs are consistent. And you have these two properties of positive and negative introspection. That is, you don't have any uncertainty about your own beliefs. That's what it means, right? You don't have any uncertainty. You know what you believe. Your beliefs may be false. Serial, transitive, and Euclidean does not require that W is itself in the modal base. It doesn't say reflexive. Okay, doesn't entail that. But it has all these other nice properties. At deontic modal base, I already said, actually less is assumed about deontic modal bases. Nothing at all here with regard to these transitive and Euclidean things. That doesn't come up in the literature. But it is generally assumed that, well, actually two things. First of all, two things are important about deontic logic. First of all, it's not reflexive, not realistic. That is, the obligations can be violated. And secondly, something that people do sometimes assume is that it's serial, that it's consistent. But I said already, you can drop that because laws or obligations are not always consistent. They can be contradictory. All right. So, for each of these readings that we saw in the beginning in this table, right, there may be some requirements of this kind that you can associate with the corresponding modal base. Okay. Now, something I have said nothing about is the third column in this table, the axioms. And like I said, well, this is what would come up in the sixth section. But I'm not sure if we should start that. What do you think? Should we do more, or are you filled up with things? We can skip that if you like. What do you think? Do you have any questions about anything we have talked about today? Still have 20 minutes. I have to do something. If you don't have any questions, I will say something about frames and so on. We don't need that really. Yes.
質問が。
はい。
大丈夫。大丈夫。
いいですか。
はい。モーダルベースはこの一番初めに言葉の定義を決めたときは文のその文をすべて真にする世界の集合というふうに言葉を導入しました。ね、で、後でやったときにモーダルベースとして与えたのを R として R を与えることを、モーダルベースとして与えるって言ったときにその間ギャップがあると思うんですけど、それは R を決めたらその要素論理の論理式に対してはそういうファイの要するにファイをすべて真にする外縁がどうなるかを決定できるから R を決めることがモーダルベースを決めることになるんだっていうそういうふうに言いつけたい。
はい、はい、そうです。だからそのモーダルベースというのは 同じ言葉、例えば名とか must とかね、それは同じ言葉が、エピステミックでも、ディオンティックでも、いろんな読み方があるからね。それで同じ文章、John may leave とか、John may be in his office tomorrow。それは例えば、研究室にいる可能性があると、研究室に来てもいいとか、許せるとかね、許可があるとか、そういう2つの読み方があって、1つが真になって、1つが偽になる世界があるでしょ。同じ世界でも1つが真で、もう1つが偽。文章が同じだけど、何が違うかというと、モーダルベースが違う。つまり、ディオンティックの場合は、ここの可能世界の集合を決める。それでその、エピステミックとかね、可能性があるという読み方だと、なんか違う可能世界の集合になる。それで一つは確かに彼が研究室にいる世界が入っているけど、ここには入ってないとか、そういうことがあるから、R はその曖昧さをなんていう解決ですね。resolve、ambiguity、曖昧解消することになる。大体もちろん文だけを見ると、英語の場合にはね、名とかそういう場合には、どちらかわからない。日本語だと明らかですね。今言った2つのいる可能性があると、なんている許可をもらったとか。そうです。はい。
もう一つの質問は、これターミノロジーのことですけど、僕知らないから教えていただけたらありがたいですけど、
はい、
そのユークリディアンというのはどうしてユークリディアンというのかちょっと伺いたいです。
それは僕もわかりませんね。なぜでしょうね。ユークリディアン、ジオメトリーに関係あるはずだけどね、なんかあまりピンとこないことは確かだけど、今はそれしか言えないかもしれないけどそうだね。ユークリディアンスペースの距離の概念に関係あるけど、ちょっと説明するのは複雑だから今なんか難しいかもしれない。これは、変なことは、ここには距離という概念がない。だからなんでユークリディアンというですね。知らない。他に何かありますか？
すみません。
はい。
ついていけてなかった。
はいはいはい。
コンシステンシーとシリアリティがどういうふうに。
何について？
コンシステンシーとシリアリティが、どういうふうに
つながっているかとか、どんな関係あるかですか？それはそのモデルベースについて2つの見方があるということです。一つはモデルベースというのは可能世界から可能世界の集合への関数だというやつですね。つまり、可能世界を与えて、それでその値が可能世界の集合だ。でその集合が必ずどんな可能世界を与えても、その集合がノンエンプティじゃなければいけないというのはコンシステンシーでしょ。はい。それがコンシステンシー。それは一つの見方だ。つまり可能世界、モデルベースがそういうファンクションだ。もう一つの見方はリレーションでしょ。それだと全く同じ条件がシリアルということになる。なんかちょっとここにこれが W で、これが RW で、何か少なくとも一つぐらい入ってなくちゃいけない。ねW1 とすればこうなるけど、W2 でも、なんかこれは RW2。ここにも必ず一つぐらい入ってなくちゃいけないとか。ね、それがコンシステンシーの条件になる。でしょ？はい。それでこの、全く同じことはその矢印で表せば、必ずなんかどっかに行くことができる、ね、矢印があるという条件になる。それの2つの見方です。モデルベース、ファンクションとしてとリレーションとして。それに他のもリアリズム、これが一つのファンクション、そのファンクションの見方で、これはリレーション、同じことです。リフレクシビティとこれのリアリズムとか。本当に文献を読むと両方出るから、その関係が何かちゃんと知っておくと読みやすいから、ちょっとここで強調したけど。
同じリレーションと同じ R を使ってるっていう。
それはちょっと、
意味がある。
あんまそうしない方がいいですか？そうですね。同じものじゃないからね、確かに。ただ、本当に関係が密接だからそれにしたけど、そうしない方がいいかもしれないけど、ちょっとあるとわからない。それが問題になりましたか？その同じ R を使っていたのは良くなかった？
それはあんまり分かりにくい混乱するとかいうことはない。
ありがとう。じゃあ何が混乱の元になりましたか？
いや今のはただ単純にそのシリアリティリレーションに関するそのシリアリティっていう性質と、モーダルベース考えた時のコンシステンシーっていう性質がなぜ一緒になるのかわからない。
でもそういうふうに大体同じことを言っているということですね。そして明日クラッツァーの論文を読むときに大体こういうふうにいろいろ表しているけど、イントロスペクションについて何も言ってない彼女は。でも他のこのリアリスティックとかモーダルベースについてこういうことを言っているけど、大体他の文献、例えばストーンネイカーとかそういうのを読むとこの観点から使っているから、どういう関係か知っておくべきだと思います。でも表を見ればわかるじゃない、ちょっと少し気を使われているかもしれないけど、でも慣れてくると思います。じゃあ他に何か質問がありますか？なければ、実は6に入りたくないんです。10分しか残らない、9分しか残らないから、これで何か、やめましょうか。いいですか？そういうことで、明日はそのクラッツァーの81年の論文について話します。それはもうそのモーダルベースとモーダルフォースにもう一つ加えることになる。そのモーダリングソース。それは明日の一番大きな話題になるから、そういうことです。